Now that we've had a formal introduction to the types of data sets that data scientists often use, it's really critical we talk about how to formulate data science questions. So in this video, we're going to discuss the properties of a good data science question, and then walk through a few examples of data science question formation so that you can start to familiarize yourself with the process of formulating a good data science question. So if you are doing the group project or anytime you're doing a data science project, be it as a group or individually, you have to first sit down and think about what it is you want to work on. I encourage you, if you're doing the group project in this class, to really think about what you're interested in. Think about a question you actually want to know the answer to that you don't know the answer to currently, and formulate a strong question. Do this before you ever start looking for data sets. Um, and what you're going to want to do when you sit down to brainstorm, and you'll probably have to go through a whole bunch of iterations and brainstorm to get to the right question, you're going to want to settle on one that is specific, can be answered with data, and makes clear exactly what is being measured. Now, why is this important? So I'd like to take a second here to talk about the nature of a data scientist and say how it differs from a mathematician or a computer scientist. So inherently, of course, data scientists, it's in the name, are data-driven. I mentioned that answering interesting questions with data is the goal of a data scientist, which means that they, one, have to be driven by the data itself, and they have to care about the answers, right? We don't ask questions just to ask them. We ask them so that we can answer them. And we care that about the answers that we come to are accurate. So the analysis of the data to discover something new about how the world works or how our company works is really what we're driven by, which means that we care that the answers make sense. So we care about what the answers mean. I don't run code just to get it to run. I do it to answer the question. So that output and ensuring that it's right and that it makes sense is really critical. We're going to touch on this third bullet point in the data intuition video. The last two bullet points are really critical and a comparison to, say, a pure mathematician. Mathematicians love solutions. They do the work because they can come to a pretty solution at the end. That is not how data science works. And this is because nothing is ever completely true or false in science, and in data science, there's always gray area. We have to deal with the fact that data are not perfect. They are collected by individuals, they have biases. We don't always have exactly the data we want from all the people that we want it from, and we have to deal with these limitations. The same goes for analysis. There are often multiple paths that are reasonable, and we have to be okay that there is this gray area, that there isn't one perfect solution. So while we're data-driven and care about the answers, we also have to be okay with the fact that there are going to be limitations to almost every data set and every analysis that we do. Okay, so with that aside, what is the data science process? If you Google image search data science process, you'll see a whole bunch of similar images. This one is probably one of the ugliest, but I think it's the one that explains it the most clearly. So here, the data science process starts with asking an interesting question. Notice that this comes before you try to get the data. And there are specific questions over here that can help you guide your thinking when you're doing a data science process. So after you ask an interesting question, you get the data, see if you have the data you need. You then explore the data, model the data, and communicate and visualize the results. Now notice that there is a path to go backwards. Sometimes you ask an interesting question and then get the data, realize that you don't have the data you need, and then have to reformulate asking your question. But this process starts at the top with asking an interesting question. Which brings me to this quote from Einstein, who said that if I had an hour to solve a problem and my life depended on it, I would use the first 55 minutes determining the proper question to ask. For once I know the proper question, I could solve the problem in less than 5 minutes. And I think this really rings true. Formulating data science questions is an undervalued skill. Going out into the world, nobody's going to tell you what questions it is to ask and answer, and it's up to you to figure that out at your company or in the lab that you work in. And you have to be good at formulating data science questions. And this is sometimes where people who are more technical struggle. They have not been asked to do this, so know that this is a skill and it does take time, and it's okay if you and your group sit down and spend a bunch of time figuring out what the right question is. Formulating the right question makes the analysis and everything downstream a lot easier. It's worth spending the time up front. Okay, so what makes a question a good question? I alluded to this in an intro slide, but to spell it out specifically here, science questions should be specific. I'll show examples of how we get to specificity just in a minute. Be answerable with data, because they're data science questions, and specify what's being measured. It should be clear from your question what information you're going to be using to answer the question. So, what does the process of working toward a strong data science question look like? I'm going to go through 2 examples in detail and then quickly through 2 more. All of these come from former COGS 108 projects, and the links to the ones I'm explaining here are included at the bottom. So this first one has to do with politics. Say you and your group sit down and you all realize that you care a lot about politics and you want to better understand American politics. So you could sit down, and the first question that you could have is what impacts politics in America, right? Like, this is a general question. It's too vague to be a data science question, but it's a good starting point. We all have some idea of maybe what this question means, but it's not specific yet. We don't know what's being measured, and we don't really know what it means to impact politics in America. So as you start to get to specificity, maybe your group realizes you also really care about pop culture and you want to understand the relationship between pop culture and American politics. So you start to improve on your question and ask, does pop culture have an impact on American politics? Again, starting to get more specific, but not yet specific enough. And maybe you're like, okay, well, what in pop culture are we going to measure? How are we going to understand this relationship? And you decide that American TV shows and its impact on American politics is what you're really interested in. And as you iterate through, you realize that maybe South Park is really what you think captures the relationship between American TV shows and American politics. So you start to look at the show South Park. As you continue on, you ask, is there a relationship between words in South Park episodes and American politics? So we're getting much more specific here. We start to understand what data are going to be used. There's going to be some data from the words in the South Park episodes. Now, we haven't gotten to the American politics side yet, so we have to keep continuing on. And we know now that we're not just going to look at some relationship between words. We want to know about the sentiment of political words and American politics. And finally, what about American politics is it that we care about? We care, is there a relationship between the sentiment of political words and South Park and America's presidential approval rating? And this is getting at a specific data science question that is answerable with data, and that makes it clear exactly what it is we're going to be measuring to answer this question. For your final project, you may have one overall question, what impacts politics in America? And then maybe you have 3 sub-bullets. You have 3 points where you have specific sub-questions that make it very clear what it is you're setting out to do. The second example I wanted to use is from a project this past quarter, where this group was interested in understanding flight delays. So maybe they sat down and they thought to themselves, okay, we all take a whole bunch of flights to get home, to go on vacation. Why are the flights I take never on time, right? Somebody could feel that way, and maybe it's true and maybe it's not. But what affects this? So that's the too vague question. You could iterate on this question and say, what causes delays during travel? So you want to know that specifically we're going to measure something about delays. Improving on this further, you want to know what you're going to measure in travel. So maybe certain airports have more flight delays than others. Still a little bit too general. Getting closer is, does the likelihood of flight delay depend upon where the flight starts or ends, right? So airports have both arrivals and departures. So just looking at airports might not be specific enough. We want to look at flight departures and arrivals. Now, after that, you'd probably say it might not just be delays, it's probably delays, cancellations, or diversions that depend upon where a flight starts or ends. So now it's specific, getting an answer to this question that we can do using data. The last 2 here have to do with cause of death, and I want you to take a look at this to see what gets attention in the news and how that relates to what is actually reported by the CDC. The last one here has to do with policing. There have been a lot of great policing COGS 108 projects previously, and this group wanted to know about police response time, and by the time they got to a more specific question, they asked where police cars should be stationed, accounting for crime levels and time of day to make police response times equitable throughout San Diego. So this is the idea. You start with this first question that you have while you're walking down the street, like, why isn't police response time always the same? And then get it more specific, ensure that it's answerable with data, and make sure that it's clear what it is that you're going to be measuring. And that's how you go through the process of formulating a good data science question.